Shall we start, right? I'm sharing my screen. So would anyone respond to whether the screen is visible? Is my screen visible? Okay, that's good. I can hear you too. That is very good. So before going to my slides, just want to show you that my active role throughout this course will be to guide you through the assignments, and obviously to you can see here ask a question, right? So you can click here and you can ask a question. So I'll be available here. I'll be uh, happy to help you out throughout any doubts throughout this course. And yeah, so that is what my primary focus would be throughout this course. And then I would be let me start the slide. I hope I'm recording. Yeah, I'm recording. So guys, my name is Tanmay Sharma, and I am a Prime Minister's Research Fellow from Mechanical Engineering Department of IIT Patna, and I have been allotted this opportunity to be a teaching assistant in the NPTEL course, that is Power Plant Engineering, and my primary task will be to arrange live interactive sessions and to basically guide you through the assignments which have been allotted. So it is a live interactive session, right? So I would be really very happy if others would interact with me verbally. And since I am presenting now, I do not have access to the chat, so I won't be able to read your doubts. So please go ahead and ask me regarding in any point of time. And okay, so there will be a slight problem because I won't have access to here, so I won't be able to admit anyone who will be entering here. Anyways, so I think we should start. It's already 9 minutes past. Okay, so this session that we'll be having will be basically recorded, and I will be making it available in the YouTube. Everyone here will be getting the links. So this recording will be shared to everyone, and you can go back and look at it whenever you feel a little bit confused regarding whatever we have discussed here. And so yeah, you can ask me any questions which you need to answer, and if I'm not able to answer in this session, I'll be looking to it and be posting in the doubt forum, or will come out in the next session. So yes, so this session will be basically about the assignment 0 that we have been allotted. And assignment 0 was a basic introductory practice questions which gives an overview of the whole course that we will be studying here. Okay, so power plant engineering, and basically we'll be learning about the components of the power plants, like the Rankine cycle, then other types of power plants, the sources of where we can generate our useful work. So these kind of things will be discussed in this particular course, and there will be a lot of problems, mechanical related problems, which we'll be solving in this particular course, which will help us think like an engineer, how to develop a particular plant, or how can we maintain a particular plant. So in assignment 0 there were 10 questions, right? So I'll be trying to go through all the questions here, and I'll be explaining them, and I will be giving you simultaneously an overview. Is there anyone having any doubts till now?
Sir, option C होगा sir.
Yeah, that's very good. I hope that everyone has solved this assignment. So in this session I'll be discussing the answers as well as the solutions. So you need not answer me, but that is very good. It's option C. So why is it option C? And that would be in detail covered in the course. but here I will be just giving you an overview of how to think on it. Since we are all new to the course, so we'll be getting deeper and deeper slowly. So right now if I go a little bit deeper, then you might not be able to understand. That is why I think that it would be better for me if I will give an overview of what we'll be studying in this particular topic, such as Rankine cycle. So what we'll be studying and how to answer these particular questions, which will help you in the upcoming assignments. So this is the first question, and here directly it was given that this is a TS diagram, and this is the TS diagram of Rankine cycle. Laser pointer, and which process represents a reheat. So this is a reheating Rankine cycle. So most of you, I think, they might not be familiar with a Rankine cycle itself. So here I am trying to demonstrate this to you, but this will be demonstrated better in the courses. So this is a basic schematic of a Rankine cycle, and here first of all I am trying to correlate with this particular figure out here. This is the TS diagram, and I have arranged all the elements of this Rankine cycle according to the graphs that you see. So first let me start with this 4 to 1. This is a pump. Then
option 3.
Yeah, okay, good. Then this is the boiler, pump to the boiler, and the process of the boiler will be 1 to 2. This is 1 to 2. Then from this boiler, this is the turbine that is connected to the boiler. The process 2 to 3 dash will be this 2 to 3 dash. This then the turbine, the outlet to the turbine is connected to the condenser, and its particular process is 3 dash to 4. So this is 3 dash to 4. So this is how I am arranging so that it would be better for you to understand. So basically what a Rankine cycle does is that first of all we have a boiler, and here in this boiler we have water, normal DI water. So this DI water that or feed water that we have here, so this will be given heat, and taking the energy from the heat energy that we provide, it will start to boil and steam will be produced in the boiler. So boiler is mainly designed to produce the steam in saturated or super saturated conditions. So what do we mean by saturated or super saturated conditions? For that we will have to refer to this TS diagram. I hope that I am not going too fast. If I am going, then please stop me in between and remind me that I am going too fast. Okay. So in the boiler what we do is that we supply heat energy to the steam. So let us understand how we do that. So this is a TS diagram, this is a TS dome that we can see. So the significance of this dome is that this side, in the left side of this dome, there will be completely liquid. On the right side of this dome, there will be completely gaseous state, and in between the dome it will be a mixture of both liquid and gaseous state. So at a particular temperature, you might be knowing that when the phase changes, it happens at a particular temperature, right? So this constant line is a constant temperature line. You can see the phase is being changing from this liquid state to this point, the vapor state. So in between you will have many configurations, such as there will be some percentage of liquid, some percentage of vapor, and total will be the mass will be obviously conserved. So in this particular part there will be more percentage of liquid, less percentage of converted vapor. Here more percentage of the converted vapor and lesser percentage of the liquid. So this is called as the wet steam, and is described by the quantity dryness fraction, or dryness fraction. So this is the wet steam that we are talking about. So first this is liquid, it gets it takes in the this is one, you can see this particular line here. First of all, it takes the heat energy in the form of sensible heating. You might be knowing there are two types of heating, that is sensible heating and latent heat. So sensible heating, the temperature increases along the constant pressure line. This is going along the constant pressure line. Then we are still supplying the heat, right? So at this point it will still take in the heat, and it will get converted from liquid to the vapor at this particular point. Again, when it is out of here, it will be completely saturated steam at this particular point, and it will still take in the heat because we have more heat to provide. So it is still taking in the heat, and it will slowly go to this point, that is point number 2. This is called as super saturated steam. because the temperature of the steam is not the temperature out here, the corresponding to the particular pressure. So it is having higher temperature, so that is why it is called as the supersaturated steam. And so this particular point is corresponding to here, that you can see here, and one is before we supply the heat, that is coming from the pump. So from pump it is coming here, we supply the heat and it receives the sensible heat, then again the latent heat in between, again a little bit of sensible heating, so that it gets to point 2, that is a supersaturated condition. After it goes to supersaturated condition, we have provided enough heat energy from coal or other forms like oil, then gas. So from these sources we provide the additional heat. Then
Steam.
is there any question?
No sir, no.
Acha, okay. So from point 2 till point 2 we have supersaturated steam at much higher energy we have provided from the heat source. Now we have given the heat source, now it will go and get connected to the turbine. So our main objective in a Rankine cycle is to get work, right, to convert from heat energy to work energy. And the work is that we need the electricity, we need the fan to work, right? So where to get the electricity? So this is the cycle that gives us the electricity, the work done. So how it does is that it takes in the heat, the steam is at very high temperature, high energy, it goes to the turbine and it strikes the turbine blades. So in a turbine there will be turbine blades, and this high pressure steam will be coming and getting collides with the turbine blades, and the turbine blades will start to rotate. So as the turbine blade starts to rotate, it is connected to a mechanical shaft, and this shaft will again be connected to an electric generator through which electricity will be produced. So you can see here how heat energy being added to this boiler, and it is getting converted to rotational energy, mechanical energy or work done in this turbine, and this mechanical energy is later converted into electrical energy by electrical generators, which is currently being worked out by the electrical engineers out here. So our main objective was to supply heat, get work, and this is being performed by the Rankine cycle. But yet to get to these particular stages, we still need other components. Then let us discuss why do we need other components. So at the turbine exit, so it will now have released all the energy of the steam to this turbine blades, and so the energy is lost to the blades, and so the energy is less. So this 3' point will be this 3' point. I am talking about simple, very simple Rankine cycle, nothing of reheating, regenerative, nothing of like that. So simple Rankine cycle, it will go from process 2, lose all the heat energy, enthalpy, and then it will go to point 3 dash. So here it will be at a lower temperature. So at this lower temperature it would be still a wet steam, right? So it is still there is some amount of steam here, means a gaseous state, and some amount of liquid state. So at this particular point 3 dash, you will have to cool it down. You will have to cool it down so that you get to this point 4. So how to cool it down? We use the condenser. So in condenser you cool down the steam and you follow the process 3 dash to 4, and you will cool it down up to 4. And in point 4 there will be a pump. So at the exit here at this point, so this side was completely liquid, right? So this is saturated liquid. So saturated liquid will be now need to be delivered to the boiler, right? Its pressure needs to be slightly increased. So the pump delivers the saturated liquid from the condenser and then to the boiler. So if these two components were not there, which was not either taking the heat energy nor it was producing the work, we won't be able to make it a complete closed loop. That is why we need these two components also, 3 dash to 4 to cool the steam to this particular point, and then again to supply the cooled steam, that is the liquid state, to the boiler. So that is through the pump. I hope the Rankine simple Rankine cycle is clear. Now in a more complicated Rankine cycle, because the simple Rankine cycle is not giving us high enough energy efficiency, so we employ certain other accessories to enhance the efficiency of the Rankine cycle. So what we do is that this this pipeline, a boiler to turbine, we replace this pipeline, simple pipeline, with this particular system. Now what happens is that the steam coming out of the boiler, it is having very high energy, so this particular point 2. Now we will be first passing it through a high pressure turbine. Okay, we will be passing it through a high pressure turbine. The same you can see here. So it is going through the high pressure turbine, its enthalpy is decreasing, its temperature is decreasing to the point T2 2 dash. So this is 2 dash. Again, what you do is that at this particular pressure, exit pressure, we again supply this saturated steam to the boiler, saturated or wet steam to the boiler. Then it acquires the heat again and it gets converted into supersaturated steam, but at a lower pressure. So you see, these are the constant pressure lines. These are the constant pressure lines. Then here again, from here, this is the constant pressure line. It will go like this. So here also you can see this will be the constant pressure line. It goes here and then again comes down here. Now the pressure from this constant pressure line, it has decreased to this constant pressure line. Hence its pressure has decreased, right? So at this pressure outlet, it gets reheated through the boiler. It extracts the energy, some more amount of energy, it extracts it from the boiler. Then again it goes and gets connected to the low pressure turbine. I hope now you can understand why it is called as the high pressure and the low pressure turbine, because now you can look at this point 2 and 2 double dash. So this 2 is at a constant pressure which is higher pressure, and this 2 double dash is at a pressure which is lower than this. How you can say that is lower? You might be confused by this particular straight line, right? But do not get confused. So this is a line constant pressure process. So the constant pressure process will look like something like this, and this, for this constant pressure pressures will look something like this. It will go through here and will come through here. Definitely the process, the pressure at point 2 double dash is higher, is lower, sorry, it is lower than 2. That is why the point here 2 to 2 dash is through the high pressure turbine, 2 double dash to 3 is through the low pressure turbine. So at the low pressure turbine exit, you will have finally the wet steam that we first had in the simple Rankine cycle at the that particular temperature condition. But yes, you can see that the quality of the steam here, it will contain more content of the liquid, right? So it is farther away from this particular point. So you see the liquid slowly gets converted into gaseous state, right? So here the amount of liquid will be higher than the amount of liquid in here. So you do not want that. Why you do not want that? Because the more the liquid at the exit, the more the liquid the turbine blades will get into contact, and the turbine blades will get rusted. So you do not want high liquid content at the end of the turbine. That is why this point is favorable, and the reheating cycle is also producing more energy. Also it is making the suitable condition for the exit steam. So at this point, point 3, it goes to the condenser and the same process continues. So now you can figure out what is the question. The question is the reheat. What is the reheat in a reheating Rankine cycle? So the reheating is this particular part when it goes to the boiler. So 2 dash to 2 double dash, 2 dash to 2 double dash, it is the reheating cycle. So the answer will be this. I hope everyone has understood what the simple Rankine cycle, what it actually does, and what a reheating Rankine cycle does. And for your information, let me tell you that reheating Rankine cycle is not the only one of the only one other type of Rankine cycle. We have other types also, like the regenerative, then organic Rankine cycle. So these are other types which will be taught in more advanced, means more finer details in the course, but here since we are only discussing the assignment problems, I think this should give an idea, and also you will find it a little bit easier to solve the next few problems. So is there any question till now? I would love to answer it. Please go ahead.
Sir,
Yes.
what is the basic difference between reheat cycle and a regeneration cycle?
For that, as I have already told you, the regeneration cycle I haven't taught here. In the regeneration cycle, what happens is that from the different parts of the turbine, it is again going to the condenser. So actually, this particular concept, it will be more taught in more finer details in the course. That is why I do not want to go into that. But yeah,
Okay.
but yeah, see here you can see there are two turbines, right? In a regeneration cycle there will be one turbine, but in one turbine from different parts it will come to the condenser. So that is the difference between a regeneration and a reheat cycle. But yes, again, it will be taught in more finer details in the course. But if you have any doubts from what I have taught here, please go ahead.
And sir, in this reheat cycle,
Hmm.
how do you decide at what pressure you have to reheat the steam coming out from the high pressure turbine? At what pressure, how do you decide that? At what pressure you have to reheat?
Good, good. That's a very good question. So these are practical points of view. So what happens is that from 2 it is coming to 2 dash, right? So why this point? Why not can we go a little bit higher? Why not we come a little bit closer? So there is a particular pressure difference. P2, P2 dash, and P2 dash, and P2 double dash. So this the ratio of these pressures, so these play a very significant role. But that is from the derivation point of view. From the practical point of view, let me tell you. So this point is at a saturated point, saturated condition. If you come a little bit below, it will be wet steam. Again, a wet steam is not favorable for the Rankine cycle, the pressure turbine. So we will have to think about something. It will go only till 2 dash. So you can see the pressure curves are like this now. So if I draw a pressure curve which will follow this particular point, so it will come like this, slanting here, and again go through a straight horizontal line, again go here, right? So this particular pressure point is the different, this is different. So here it is it is again a different pressure point. So we are decreasing the pressure up to this point where the exit conditions of the steam are not wet steam, it is a saturated steam, so that it is not harmful for the turbine. But again, that is dependent upon this end condition, the 2. If you select higher temperature, so it will go a little bit beyond here, right? So again, if you decrease, it will come isentropically. Let me tell you, a process in a in a turbine is generally considered to be isentropic, but there are some correction factors which we will be learning in the course, obviously. So this is isentropic, so it will come down vertically. Again, you see the point of intersection would be out here, so the pressure here is different, right? Now you will have to check what is this starting condition. Based on that, if I am getting a superheated steam or not. So these are few conditions you will have to take care at which pressure you will have to do the reheating. So did I answer your question?
Yes, sir. And I just wanted to know, since there was a question related to regeneration in assignment 1,
Acha, acha.
do these both reheats and regeneration processes, do they increase the mean temperature of heat addition, or any one of them only increase the mean temperature of heat addition?
The
Because
mean so first of all, actually I was prepared for only this assignment 0, but yeah, what you have asked is that the mean temperature, it depends upon the total area of the TS diagram, right? So whichever process, whether the reheat process or the regeneration process, if it increases the total area of this whole TS diagram, that will increase the mean temperature. So which process is doing that? You think from that point of view and you will get your answer.
okay, okay, thank you.
Okay, welcome. So are there any more questions, or shall I move on forward?
many times can we reheat the steam?
As many time it is proving economical to you, because see, you are also installing a new turbine in between, then it is increasing your means capital investment. Again, your maintenance costs are also high. So these are practical point of view, but there is also one condition, that is the pressure ratio between the two. The pressure ratio between the two, that should be something which you will be deriving in the next few means the classes ahead. So that is one of the factors which determines how many times you can reheat. But yes, from practical point of view, you are increasing the bulkiness of the system, you are increasing your cost, the maintenance. So you will have to think the minimum time you can reheat to get the maximum time, maximum this efficiency. So that's how you can means think. There are efficiency calculations for this. Efficiency calculations. So from that you will get a better idea of how many times you can reheat, whether reheating is good or bad. Okay.
And is it necessary that the temperature at 2 double dash should be same as 2, or
No,
can
no,
it
no.
be more than the?
It is not necessary, but I think it is what you will get, because it is going through the same boiler, na?
Yes.
So I think if you're passing it through the same source, then the sensible heating at the exit will be the same. But yeah, it will depend upon the time, but it is not necessary to have the same these conditions.
Okay, sir. Thank you.
Okay, okay. So moving forward, so I acha is
Sir, one question, sir.
please.
The reheat temperature is always greater than the main steam temperature, which is laid in the high turbine, high pressure turbine.
Sorry, I didn't get it. Please repeat.
Yeah, I'm just saying the temperature, the temperature of the steam which is inserting in the high pressure turbine, this is lower than the reheat temperature.
Acha.
If you because I'm just working for many years in the power plant, the reheat temperature is, if you see in the supercritical power plants, that is around 580, more than 580. And the main steam temperature, which is means the inlet of the SP turbine, is 565.
Okay.
But I think that I have seen this diagram, that is the showing the temperature on 2 and 2 double dash. Both are showing equal.
Equal. So I think you will be more equipped to tell us more about this power plant that, right? See, say please, do not get me wrong.
Because we are using the superheater, sir. This is the superheat.
Okay. You are using the superheater, so that is basically increasing the temperature of the steam.
Temperature, yes.
Okay. So that thing is not here.
Yeah, that is the superheating. That is the more than the critical point of this Rankine cycle.
Acha.
800 megawatts thermal power plants, all are the supercritical power plants.
Okay, that's a very good insight from you. Thank you so much, sir. Okay. So the 2 dash, you were saying that it is generally higher.
Yes.
But here it is showing equal, right? So
yes, you can see the diagram that 2 and 2 double dash temperature is almost equal.
Okay.
But now some technology has been improved, and by using the superheater, the temperature goes to more than this critical point of the Rankine.
Okay. That is supercritical plants, na?
Yeah, supercritical. Yes, supercritical.
That's
the pressure and temperature of the main steam is always higher side.
yes. So you are talking that this is the critical point, so the temperature will be higher than this critical point. Okay. So I think there are many kinds of plants, right? I mean, obviously you will have more information about the power plants than me, because I'm a theoretical guy. So if you feel to share anything more, I think the crowd would also love to know that.
Something I will add on.
Sure. So the main purpose is this. Let me get everyone straight. That main purpose is this. This is a live interactive session, so there's nothing to hide from anyone, because we have other practical knowledges. So I think it would be better to discuss and have a good knowledge after that, right?
Sure,
Okay.
sir. I will add on during this session. Don't worry.
Okay, sure. Thank you so much. Thank you so much. Okay, then I'm going forward. Now, yeah, this is one of the point why the maximum content of moisture. What is the maximum content of moisture allowed at the turbine exhaust in steam power? Maybe sir can explain. Hmm.
Less than 15%.
Right. This is so. This is a standard condition that is applied in the power plants, right? Am I right?
Yes, yes.
Ha. So
The
basically,
total moisture in the coal should be near or less than from the 50%.
right. The maximum can be 15.
Yes, yes.
So basically we are talking about this point, the exit of the this turbine. So the exit of the turbine should be more towards this end point. The more it is towards this end point, it is towards the saturated point of this dome, the more it is favorable for the turbine. So the turbine, if it is getting exposed to more moisture, then obviously it will be more prone to the rusting and other maintenance hazards. So that's why we are trying to get it towards this particular point. And you can see sometimes it is also out of this particular point. So that is the thing. The maximum you can go, the maximum you can come to this side, means from 3 to 4 side. So that it can be only 15%, means there should be from 0.4 to 0.3 dash, there should be at least 85% of the means the steam and 15% of the moisture content. So that is why the answer is 15%. That is the maximum content. Then the power cycle continuously converts dash into dash. So I think you must be now getting the idea. So it is converting heat addition into the boiler, and we are getting the work output, so it is heat to work. Yeah. So next is, what is the function of the pressure gauge in the boiler? Now let me show you a pressure gauge. So yeah, this is obviously a random image from the internet, but if you can go to the power plant, and you can see that steam drums are really very big, and there are pressure gauges, safety valves and everything installed into the pressure drums. So this is one such kind of pressure gauge you can see here, and this is mainly to measure the steam pressure, because what we are doing in the boiler, we are generally boiling the water coming in and the steam is being produced. So if the steam pressure is not within the range, means the outlet condition is not within means it is higher or lower than the expected range, so we will have to somehow release the pressure from this boiler, and we will have to maintain that pressure. That is why a steam pressure gauge is available in the steam drum, and to indicate the steam pressure. So this is the answer. Then we have what type of valve is a feed check valve of a boiler. So this is an image again from the internet. So this is how a feed check valve looks like. Basically what it does is that it controls the flow of water from the feed pump to the boiler. Okay, so you have a pump and you had a boiler, right? So from the pump, from below, it is delivering to the boiler. So that is the in between you have a feed check valve to control the flow rate from the pump to the boiler. Again, one more thing is that it prevents the backflow of water from the boiler to pump when the boiler pressure is more than the pump pressure, or when the pump feed pump is malfunctioning. So what happens is sometimes is that from the boiler it again comes back to the retraces the backflow and comes back to the pump. So that is also not required. That is why you need only one the valve which can only supply in only one direction to prevent the backflow. That is why the answer will be one-way valve, and this is why such kind of valves are used, feed check valve. Yes, please go. Sorry, I didn't get you.
What is the need by malfunctioning here?
Meaning of acha, feed pump is malfunctioning. So what happens is that the not all equipments are reliable, right? Whatever you are using, it may go bad in some particular time, or maybe there is a power shortage or something like that, short circuit or something. So by that, the feed pump which was being operating, so feed pump, let me show you. So here in this diagram, this is a pump, right? From the condenser, it is going back into the boiler. So here we will have to control the rate. Also, there is one another inlet, means if we observe that there is some leakage inside the boiler, because this is not a completely closed line, right? So somewhere there might be some leakage also. So in order to increase the amount of water into the whole circuit, we'll have to supply some water. So that also can be done through this feed check valve. So these things, to do these things, you do not need the water to come back from where it was flowing, right? So sometimes the pressure inside the circuit will be so high that it will try to not try to get the water into the system, but it will try to expel the water. That is why these kind of valves are used, which can only flow in only one direction. We can only make it flow in one direction and provide the backflow. So is your question answered?
Yes, sir. Thank you.
Okay. Next, role of breaker house in coal feeding. So actually I this particular thing which I read from the internet also. So here the coal feeding, which meant the regulating the amount of coal to be supplied into the mills as per the requirements of the boiler. So the boiler, it is getting the heat energy. So the heat energy is being supplied from the coals by burning the coal. Now in the coal mines, what happens is that a light dust is being produced. So it is a tendency of the coal, when it is being transferred from one place to another, light dust are being produced, and these are not suitable, not even suitable for in terms of health, also not suitable in terms of burning. Yeah, you can talk about grinded coal, that is different. Light dust is something which is flowing in the air, so that is not means that is an unessential component. So the main role of the breaker house in coal feeding is to separate the light dust from the coal, so that the later these processes can go on smoothly. Also the health hygiene is also improved. The next question was, which of the following is, yes sir? Yes.
I had one question regarding the previous question.
Yeah.
That coal, once it is received at the power plant, right from that storage, which are the different stages that it goes through till it reaches the boiler?
Okay, so
there are the many. First of all, the coals come from the transportation and stored at the storage areas.
okay.
From the conveyor belt, it go to the bunker, and then bunker is crush it, and then goes to the mill with the help of the primary air. And that is make it after the crushing, it is comes in the mill and it is become a powder. And the primary air which is coming from the boiler side give the heat to the coal to burn easily, because the temperature of the primary air is around 250 or 260 or up to 300.
Sir, thank you for your explanation, but would you kindly also explain what is the primary air, where it is being supplied from? I think the crowd here.
Yes, primary air is the air which is supplied to the air preheater. This is the cold air which is insert with the APH, and after the combustion in the boiler, the flue gases move towards to the chimney. So in between the combustion chamber, the economizer, then after the economizer, APH is coming, air preheater.
So let me guess it. Let me please interrupt. So flue gas is actually the gas which has been already burnt, right? The coal is being provided with air, and this air, it burns the coal, and the air which is leaving the chimney, that is the flue gas. So the flue gas is the primary air.
This the flue gas is not this cold air from the PA fan, which is go to the flue gas, and the heat is absorbed from this flue gas to this cold air. Then this cold air is heated more, and it goes up to 300. And some part of this primary air, this hot primary air, which is some part of the hot primary air, is used for the burning of the coal.
Okay. So that is a very good explanation.
Because we do not want to lose any energy from this. The heat is coming from the boiler.
Acha. Really speaking, I didn't know that because I didn't go to the power plant to see all these things. But really, thank you so much for the input. And the person who has asked this doubt, whether your doubt is cleared?
Yes, sir.
Okay, thank you so much for clearing the doubt and for this question. Now this is the question number 7. I think this is quite obvious, but let me get one thing clear. So which of the following is not a requirement for site selection of hydroelectric power plant? So availability of water, definitely. Large catchment area. So many of you might not be knowing what a catchment area is. So catchment area is the area where the rain falls into the river. So this is how the water level in the river is increasing. So you always need the dam near to a catchment area so that you can get an uninterrupted supply. Then rocky land, obviously, because you will be installing your whole dam onto a very firm base, right? You need a firm base, so rocky land is something that is good. Sedimentation, this is something which you do not need, because the sedimentation, as the river flows and comes into the dam, so there is a reservoir, right? So there, if the sediment if it is sedimenting, so the level of water is also decreasing. That is how you will be the height of means the pressure height that is falling onto the turbines below, that would be decreasing. Now this is something which you do not want. That is why the answer should be sedimentation. Then there is this I think everyone has answered, but still I am going to explain. So hydroelectric power plant is non-renewable source of energy, conventional source of energy, non-conventional or continuous source. So let me explain. So what is a conventional? Many of you confuse whether it is a renewable or conventional. So these are completely different. Renewable sources or non-renewable sources, they can also come into conventional or non-conventional sources. They might be in different categories. Renewable are always conventional. That is not the case. So the conventional sources of energy generally has been used for since a very long time. Those are conventional. It is known to mankind. So mankind has already been exhausted in using all those. That is conventional. And the examples are coal, gas, hydroelectricity, oil. These are always been used to produce energy. Then non-conventional are wind, solar, small hydroelectric plants, then tides, sorry, not hydroelectric, it is tides, tidal energy, then geothermal, heat, and biomass. So these are some things which people are now trying to understand in more depth, and was not being used for a long time. So these are non-conventional sources of energy. Now you might be knowing what is the answer. The answer is conventional source of energy, because it's being used for a long time. Continuous source of energy, I will give you one example: nuclear power plant. So these energies here, these are continuously, it is being produced, because because the source, the fuel, it is now being controlled so that it does not replicate exponentially, but it has a potential to replicate exponentially. What happens is that uranium atom, it splits, right? So it produces 3 neutrons. Again another reaction will continue, again 3 neutrons. So for initiating one reaction, you need 1 neutron, but it produces 3 neutrons. So it is increasing step by step, right? So that is a continuous source of energy. That is why it is called like that. But hydroelectric power plant, you will not find it continuous. In dry seasons, you might not get enough power from the hydroelectric power plant. So that is not an option.
What is the example you gave for continuous source?
Continuous source means it is being continuously produced. It can be continuous. There is no interruption in between. So
can you give any example for
See, like I gave nuclear power plant. In a nuclear power plant, so you have the fuel. Now you are just controlling the reaction, but not you are not starting the reaction again and again, right? You're controlling the number of neutrons getting, means the population of the number of neutrons which is initiating the reaction. So you're controlling, but you are not interrupting it, so you are no need to restart it. So that is why it is called as a continuous source of energy. Okay, so the next topic which I really kept, I have time. I think it's 4:52, so yeah, I will try to finish it quickly. So Pelton wheel is a very important topic for those who, if you are preparing for GATE, yeah, one question is sure to come from Pelton wheel. Then here the Pelton wheel is a type of impulse turbine. It's a turbine. Okay, so impulse turbine will be taught in detail in the courses, the coming course, I think in the second week, I think. So impulse turbine will be covered, but I am talking about the next part after a particular derivation. So Pelton wheel, each equipment has a efficiency, right? First of all, let me show you what a Pelton wheel is. So Pelton wheel, this is a Pelton wheel. Okay, those who are not familiar with it, what happens is that it contains buckets. Let me show you the bucket. So these are the buckets. So what happens is that water strikes this bucket from the open end. Okay, like you can see here, it strikes the bucket. As it strikes the bucket, it utilizes the energy, the kinetic energy of the water being discharged into converting into mechanical or rotational energy, like this. So this is how the turbine is working. Now the water coming through and getting discharged here is coming through the penstock from the dam here. So from the dam the water is coming in, getting discharged, it is rotating the wheel, and this is how it is producing the energy. So this is a Pelton wheel. Now these are the few variables that I have selected. So what I am trying to do is that I will try to get the maximum efficiency if I know a particular efficiency. So this might sound a little bit weird, but I am not going to derive the efficiency of a penstock wheel, a Pelton wheel, but rather if I have the efficiency, what can I use it for? So that I am trying to do. Okay, so let me give you this particular values. From these values that you can see there, so this is the area of the penstock, then the V1 is the velocity of the water being discharged striking the Pelton wheel, which is rotating. Okay, so my I think the omega is a little bit wrong, it should have been this side, sorry. So the wheel will be rotating this side, right? So the omega will be also having angular torque of this side. So this is the omega, and omega into the radius of this wheel will give you the tangential velocity at this point. So these are the things, and the rate of discharge will be QAV1. Now using these informations and one information, that is when the water strikes each of the bucket, it goes through like this, right? It splits into two ways, and it goes out like this. So it goes out from the bucket at a particular angle. So this angle is beta 2. If you know these particular things in a Pelton wheel, then you can calculate the hydraulic efficiency, which is given by runner power by water jet power. So simply I am not deriving the hydraulic efficiency, nor I am getting too deep into this, what this velocity triangle means. So this will be covered in the course. But if I have this particular equation with me, that is the velocity of the jet coming in, the tangential velocity of this Pelton wheel, beta 2 is this angle at which it is coming out, and yeah, so these three parameters, 1, 2, 3. So if we know all this, then we can get the hydraulic efficiency. And what is our question? Our question is, what is the maximum efficiency, what is the speed ratio when it is having a maximum efficiency, right? Speed ratio means what is the ratio of the here I would say, so this is moving at u speed, and this is coming, the water is coming at V1 speed. So what will be the ratio between U and V1, U by V1, so that the efficiency is maximum? So that is what we will be trying to solve. So for that we have a particular graph, that this is the tangential velocity of the wheel. So if the wheel velocity keeps on increasing, at a particular point in between the efficiency is high, after which again it decreases. So you might be knowing that, oh, so it is running at a very high speed, higher than before, so I will obviously get a higher efficiency. But no, that is not the case. In some between you will get a higher efficiency, that will be denoted by the U star. So we will be trying to derive this formula. So obviously this is the efficiency. For maximum efficiency, what we do, we differentiate, right? Simple mathematics, differentiation means the slope, and the slope at this particular point, because it is curving out, the slope at this particular point means the line, if I draw a tangential line, it will be almost equal to the horizontal, or it will be equal to the horizontal. So at this point the slope will be 0. So if I differentiate this and equate to 0, that would give me my maximum efficiency, right? So that's what I have done here. So no need to get worried. X is something, so if I divide V1, 1 V1 within this bracket, so 1 minus U by V1, and here U by V1, so these two becomes 1 minus X and X. So simply I am replacing this U by V1 by X. So this is my hydraulic efficiency till now. Okay, so simplifying that and differentiating and equating to 0, if I do that, so I will be left with only this part 1 minus 2x, and other all things are constant, because the beta 2, that is the deflection of the bucket, is not changing, right? We are not considering how much will be the efficiency with respect to the beta 2, that is will be another problem, but we are considering what should be the maximum efficiency for a particular speed ratio. So that is why we are differentiating with respect to x, and solving this you will get x is equal to 0.5, means U by V1 equals to 0.5. So V1 was the inlet velocity at which it is striking, and U is the velocity of the runner at which it is rotating, so it should be half. So U star is half U star, that is it should be V1 by 2. That's why the answer here should be 0.5, right? But the answer here would be actually 0.4 to 0.44 to 0.46, because we are considering actually the practical turbines. It should be 0.5 for theoretical, but in practically there are much constraints, and it is observed experimentally that the bucket speed, if it is 0.44 to 0.46, the efficiency is maximum. That is why our answer is 0.46. Okay, is there any doubt in this derivation? I am not talking about the derivation of the hydraulic efficiency, that would be done in much details in the course, but after that how I am solving this. So what will happen is that you will go back to this video, you will remember this lecture, and you will get a better feeling of this particular topic. So is there any doubt till now? Okay then, so my last question is, so sorry for the topic, this is not the Pelton wheel. So wind energy conversion systems, what exactly it is designed for? So I will tell you what a wind energy conversion system is. So this is a wind energy from the turbine, either the wind turbine. So it is connected to a shaft. So from here it is connected to a shaft, and this in between is the wind energy conversion system, which has many gears and all assemblies, from which we get a mechanical energy. So the simple thing, wind energy conversion system is used for converting wind energy to mechanical energy. So I have completed the first 10 questions of assignment 0. I was thinking to do the assignments each week. I hope that you'll be have to submit the assignment on August 10, right?
Yes.
So August 10. Okay, if I discuss the assignments before then you will be at great advantage, I think. Anyways, what I will do is that to make your doubt a little bit, means to make the concept a little bit easier, I'll be selecting some problems which are related to the assignments. So by getting that particular insight, maybe you will be able to solve the assignment problems. And yeah, maybe you can post me in the doubt forum which problems are really very difficult. Then I'll be getting to know that, and I'll be solving similar problems to make your concept a bit easier. By that, you'll be able to solve that problem by yourself, and you'll be getting 10 out of 10. What do you say? Right. So discuss forum. Discuss.
Will you be posting this recording on the?
Yeah. Sure, for sure. So, so this will be uploaded in the YouTube. And I think it's a very good session. Many things have come to this for the discussion, but I want to say here. So this is the forum here, right? NPTEL Power Plant Engineering Forum. So here there is a ask a question. So I need everyone to ask me questions. So by that I will get to know that you are understanding the concept, and I will try to my best to answer these questions before the stipulated time. Okay?
Okay, sir. Thank you.
Okay, then I think we are at the end of the meeting. So
Thank you, sir. Thanks.
welcome.